In identifying the attributes of my exponential function, first I know it's an exponential function because I have my a value, parentheses, b value, raised to the power of x. And that is the format of an exponential function. The a, that's my initial amount. And the b value is my multiplier or my factor. So I can look at an exponential function and know where my starting place is and what to multiply by. So my starting place, my y-intercept, is -4. So my y-intercept is 0, -4, and my factor or my multiplier is 2. Now sometimes we're talking about what the rate of increase is or what the rate of decay is. So we need to know our rate. And our rate is always the absolute value of our b minus 1. So b minus 1, we've got b is 2 minus 1 equals 1. So my rate is either 1, or I could also put it in percents. It's 100%. Okay, then my domain. Domain is always, on exponential functions, all real numbers. Let's think about that. If we graphed this particular function, it looks something like this. And if I'm looking at my left to my right, I go on forever to the left, and it's going to go down and over forever to the right. So my domain, and it's always the same on exponential functions, is all real numbers. Now my range is either going to be greater than 0 or less than 0. Those are our two options on exponential functions. So when I look at this, my asymptote, what I'm never going to pass, is 0, and my whole graph is below it. So I know that my range is going to be y is less than 0. It can't be equal to 0 because of the asymptote. Our asymptote, that's that boundary, is y equals 0. And then the last thing is this increasing or decreasing? And we always read from left to right. So as I'm looking at this going from the left to the right, I can see that it is decreasing.